Okay, so we're going to be talking about absolute value equations right now. Essentially, when you're talking about absolute value equations and inequalities, there are three cases to consider. But since we're only talking about equations, we're only going to consider case one here. This is where the absolute value of x equals some number k. The equivalent form, as they say here, is that x must equal k or x must equal negative k. Now, the reason for this is we need to remember when we're talking about absolute value is a number's distance from 0 on the number line. Therefore, the distance, depending on its position on the number line, okay, is either positive or negative, but when we're talking about only the magnitude, we only measure it in terms of positives. That's why here it could either be k or negative k, but the absolute value, of course, will just be k, a positive number. So this is what the graph would look like. Okay, we would plot 2 points on the number line, and the solution set might look something like this. Okay, so let's go ahead and take a look at a couple of absolute value equations, and we're looking at again at case one. Okay, so here is the first one. So let's say this was our x and this was our k. So if we remember, whenever we have the absolute value of x equal to some number of k, we say either it equals k or it equals negative k or opposite k. So let's say 2x plus 6 equal 5 or 2x plus 6 equal negative 5. So what happens is this creates two equations that we solve. So they're very elementary equations now. The only confusing part I think was the absolute value there. But let's go ahead and take a look at this. So it says 2x plus 6 equals 5. So subtract 6 from both sides. 2x equal negative 1. And then divide by 2. So x equals negative 1/2. That's the first answer there. And then subtract 6 over here, and we get 2x equal negative 11, and then divide by 2, and x equals negative 11 over 2. So what we have is two solutions to the absolute value equation. Okay, so you could plot these two numbers on a number line. I don't think it's necessary, but the solution set in this case is negative 1/2 and negative 11/2. So this is what the solution set might look like. Okay, and this is just a curly brace right there. Okay, so that's the first absolute value equation. Now let's take a look at another one. Okay, so this one is no different than the previous. All right, we're going to say this is our x and this is kind of like our k. So we're going to say, okay, well, this x equals this k. So that's the first equation. 5x plus 8 equal 10x plus 7. Now we're going to take the same equation and we're going to set it equal to negative the k. So all we're going to do is say, okay, 5x plus 8 equal negative or opposite of the 10x plus 7. And there we have it. And now this part we would just do some distribution and we'd solve. But let's go ahead and take a look at this one first. So I want all my x's on the left. That's my rule of thumb. So negative 10x or minus 10x, and it cancels, and then minus 8 minus 8. So we can do it all in one step. So we have negative 5x equal negative 1, and then the last step here is to divide both sides by negative 5. Okay, so here we're going to get x equals 1/5. X equals 1/5. That's the first solution. And then in the second case here, we need to distribute that negative sign. So we need to take the opposite of everything on the right-hand side of the equation. So it gives negative 10x and minus 7. Okay, let's go ahead and do that again. So we're going to add 10x to both sides, and we're going to subtract 8 from both sides. Okay, we end up with 15x equal negative 15, and then we divide both sides by 15, we get x equal negative 1. So there we have the answer to this absolute value equation as well. Again, the solution set you can write as 1/5 and negative 1, and that's what it would look like. Okay, so these are two absolute value equations that we just solved, and they're actually really easy.